Hi guys, Mr. Joseph, your chemistry teacher. I'm back with my lectures. So today's lecture is a continuation of our previous lecture on electrolysis. We've discussed electrolysis and factors affecting preferential discharge of ion during electrolysis. We've discussed the Faraday's laws of electrolysis, Faraday's first and second laws of electrolysis. So today's lecture, we want to look at calculations involving, Faraday's first law of electrolysis. Then our lesson objectives for today's class. So we're looking at calculation based on the quantity of charge passed during electrolysis. We're also going to calculate the mass and volume of substance liberated during electrolysis. Then we're going to look at the relationship between Avogadro's constant and the Faraday's constant. We'll state the relationship between both constant and also calculate the Avogadro's constant and also the Faraday's constant using the relationship between them. So please, I want us to listen attentively and get the best of this lecture. It's going to be an interesting class. So it's majorly calculations. We are just going to solve problems. We'll just be solving problems. So please, I want us to pay attention and get the full detail. So thank you very much and listen attentively. So we want to look at typical questions on electrolysis. We've looked at Faraday's laws of electrolysis, Faraday's first and second law of electrolysis. So we want to go over to calculation involving electrolysis. This is a typical examination question, and it has to do with calculation. An oxide of iron dissolved in an inert solvent is electrolyzed for 2 hours using a current of 0.800 ampere. The electrolysis product are iron and oxygen. The mass of iron produced is 1.11 gram. Calculate the oxidation number of iron in the oxide of iron. Show all your working. So from the question, you discover that iron is deposited. So we have to write the equation that takes place. That is, we don't know the oxidation number of iron. So they want to calculate the oxidation number of iron. So let's use N as the oxidation number of iron. So the equation that takes place is iron N plus N number of electrons deposits what? 1 mole of iron, which is so the next thing to do is what? A current of 0.800 ampere was passed for 2 hours. So calculate the quantity of electricity that passes through. Quantity of electricity is equal to what? The current multiplied by the time. The current is 0.800 multiplied by the time, which is 2 times 60 times 60. So we'll get, if you have to multiply that, I'm to use my calculator, 0.800 multiplied by 2, multiplied by 60, multiplied by 60. So you get 5,760 coulomb. 5,760 coulomb. So now if you look at the question, you are asked to calculate the oxidation number of iron in the oxide of iron. That means from our calculation, 5,760 coulomb of electricity deposit 1.11 gram of iron. Therefore, 55.8 gram of iron, which is the relative atomic mass of iron, which is 1 mole of iron, will require what quantity of electricity? So we'll cross multiply. So you have 5,760 multiplied by 55.8 divided by what? 1.11, which will now be equal to. So I'm to use my calculator. So 5,760 times 55.8 divided by 1.11 gram. So you have 289,556.78 coulomb. Remember, 1 Faraday is equal to 96,500 coulomb. Therefore, 289 556.78 coulomb will require how many faradays? So I have to erase this so that I'll have enough space. So when you cross multiply, you now have x will now be equal to 289,556.78 divided by 96,500 divided by, let me use my calculator, 96,500. You now have 3.0. Therefore, the oxygen number of ion is equal to what? 3. Oxygen number of ion in the oxide is equal to 3. Therefore, Fe m plus will be equal to what? Fe 3 plus. That means 3 moles of electron required to deposit 1 mole of ion, which is equal to what? 3 moles of electron is equal to 3 faradays, based on Faraday's second law of electrolysis. So the oxidation number of ion is equal to what? 3. So it's as simple as what? A, B, C. All you need to do is to attempt as many questions as possible. Thank you very much. So before us is another question, which is a typical examination question based on electrolysis. So topical questions on electrolysis. So the question before us, dilute sulfuric acid is electrolyzed for 50 minutes using inert electrodes and a current of 1.20 ampere. A different gas is collected above each electrode. The volume of the two gases are measured under room conditions. You have to calculate the maximum volume of gas that could be collected at the cathode. So the first thing to do is to write down the equation at the cathode. At the cathode, hydrogen ion migrate to the cathode. Hydrogen ion migrates to the cathode, where it gains electron and become reduced to what? Hydrogen. So hydrogen gas is discharged at the cathode. Hydrogen gas is discharged at the cathode. Hydrogen gas is discharged at the cathode. So we have to calculate the quantity of electricity that's required to discharge this 1 mole of hydrogen gas at the cathode. The quantity of electricity passed. Remember, quantity of electricity Q is equal to what? Current multiplied by time. The current is 1.20 ampere multiplied by the time, which is 50 minutes, multiplied by 60 minutes. So let me use my calculator. 1.20 multiplied by 50 multiplied by 60. You have 3,600 watt coulomb. So 1 mole of hydrogen gas is discharged at the cathode, and 1 mole of hydrogen gas, 1 mole of any gas occupy a volume of 24 dnq. So 1 mole of hydrogen gas is equal to 24 dnq that is discharged at the cathode. And it takes 2 faradays, 2 moles of electron, to discharge 1 mole of hydrogen gas, which is 24 dnq of hydrogen gas. And 1 mole is equal to 1 faraday. So 1 mole is equal to 1 faraday, which is equal to 96,500 watt coulomb. Therefore, 2 moles will be equal to what? 2 faradays, which is equal to 2 times 96,500 watt coulomb. So 2 moles of electron required to deposit 1 mole of hydrogen gas, which is 24 dn³ of hydrogen gas. That means 2 faradays, which is 2 times 96,500 coulomb, deposit what? 24 dn³ of hydrogen gas. Therefore, 3,600 coulomb of hydrogen gas, 3,600 coulomb of electricity would deposit what dn³ of hydrogen gas, what volume of hydrogen gas? So we'll just cross multiply. X, which is the volume of hydrogen gas that will be deposited, will be equal to 3,600 multiplied by 24 divided by 2 times 96,500. Let me use my calculator. 2 times 96,500 will be equal to 193,000. 193,000. So I have to use my calculator. That means 3,600 multiplied by 24 is equal to, then divided by 193,000. 193,000 be equal to 0.448 dm cube of hydrogen gas to be deposited at the cathode. So we have to convert it to cm cube since it is in dm cube. So just multiply by 1,000. So if we multiply 0.448 by 1,000, we'll get 448 cm cube. So that's the volume of hydrogen gas that is deposited at the cathode. So it's as simple as A, B, C. All you need to do is just to read the questions and understand the questions and write down the equation that takes place at the cathode. Once you get those points right, you get the answer right. So it's as simple as A, B, C. Attempt as many questions as possible. So here's another question before us, still on topical questions and electrolysis, which is a continuation of our previous lecture on Faraday's laws of electrolysis and electrolysis in general. So the question before us is a typical examination question. A molten magnesium salt is electrolyzed for 15 minutes by constant current. 4.75 times 10 to the power 22 magnesium atoms are produced at the cathode. Calculate the value of the current used. So the first thing to do is to write the equation that takes place at the cathode. The reduction takes place at the cathode. So since magnesium is positively charged ion, the magnesium ion migrates to the cathode because since it is a molten salt, so the magnesium ion migrates to the cathode. Migrates to the cathode when it gains electron and becomes reduced to what? Magnesium. So you write the equation at the cathode. Now from Faraday's laws of electrolysis, 1 mole of electron is required to discharge 1 mole of an atom or an element. So what happens is that what? And 1 mole of electron is equal to 1 faradays, and 1 faradays is equal to 96,500 coulomb. So from our equation that is given to us, so 2 moles of electron is required to discharge 1 mole of magnesium. If you look at 2 moles of electron here, it's required to discharge 1 mole of magnesium atom. So 2 faradays, that means 2 moles of electron is equal to 2 faraday. If 1 mole of electron is equal to 1 faraday, which is 96,500, so 2 moles of electron is equal to 2 faraday, which is 2 times 96,500 coulomb. That means 2 faradays, which is equal to what? 2 times 96,500 coulomb, is required to discharge 1 mole of magnesium atom, which is 6.02 times 10 raised to the power 23 atoms of magnesium. So that means 2 times 96,500 coulomb, which is 2 faradays, is required to discharge what? 6.02 times 10 by 23 atoms of magnesium. So therefore, if 2 faradays is required, if 2 faradays, which is 2 times 96,500 coulomb, is required to discharge 6.02 times 10 by 23 atoms of magnesium, then 4.75 times 10 raised to the power 22 atoms of magnesium will require what quantity of electricity? So we need to calculate that. So you cross multiply. You now have what? X now, which is equal to what? 2 times 96,500 coulomb is 193,000 multiplied by what? 4.75 times 10 raised to the power 22 divided by 6.02 times 10 raised to the power 23 atoms. So come to use my calculator. 193,000 multiplied by 4.75 times 10 raised to the power what? 22 divided by 6.02 times 10 to the power 23. So we now get, we are going to get X now will be equal to what? 15228 coulomb. So there's a quantity of electricity that is required to deposit 4.75. Quantity of electricity required to deposit 4.75 times 10 raised to power 22 atoms of magnesium. So the next thing to do is to calculate the value of current used. So we have to use the formula. I think I have to erase this so that I will have enough space. So let me erase this so that I will have enough space to carry out my calculation to calculate the value of current used. So to calculate the value of current used, you will use the formula. Remember the formula Q is equal to what? Current times what? Time. So since we are calculating current now will be equal to what? Quantity of electricity passed through divided by the time. What is the quantity of electricity? Which is 15228 coulomb divided by what? 15 times 60. The time is in minutes, so we have to convert it to seconds. You divide it by 50. So the current used now will be equal to what? Which is 15228 divided by 15 times 60. If I'm to use my calculator, 15 times 60 is equal to 900. So to calculate the value of current use, we'll now say 15228 divided by 900 is equal to, so you have was 16.92 watt ampere. So the value of current, the value of current used is equal to 16.92 watt ampere. So it's as simple as this is just to read the equation, understand the equation, and apply the formula, and also write down the correct ionic equation that takes place at the cathode or at the anode or at any of the electrode. So that is it. So let's attempt as many questions as possible. So still on topical questions on electrolysis. This is a typical question before us. It's a typical examination question. So the first question, state the relationship between the Faraday's constant and the Avogadro's constant. We have to state the relationship between the Faraday's constant and the Avogadro's constant. Now, based on what we've treated, F represents the Faraday's constant. We use F to represent the Faraday's constant. F is equal to what? L. We use L to represent the Avogadro's constant, which is then multiplied by E, which is the charge on one electron. So the relationship is equal to F is equal to what? LE, where F is the Faraday's constant, L is the Avogadro's constant, and E is the charge on one electron. Then the next question goes, when a current of 1.2 ampere was passed through dilute sulfuric acid for 30 minutes, it was found that 130 cm of oxygen measured at 25 degrees Celsius and 1 atmosphere was collected at the anode. The following reaction takes place. Use this data and data from the data booklet to calculate the value for the Avogadro's constant L by calculating the number of moles of oxygen produced. So looking at the question, we're going to calculate the number of moles of oxygen produced. From the equation, 1 mole of oxygen is produced, and 1 mole of any gas occupies a volume of 24 dnq. So if we have 1 mole of oxygen, 1 mole of oxygen has the volume of 24 dnq. So how many moles will 130 cm of oxygen have? So we convert 130 cm of oxygen to dnq. So divide by 1000. So we divide by 1000, it will be 0.13 dm3. So we now see if 1 mole is equal to, if 24 dm3 gives you 1 mole of oxygen, 0.13 dm3 will give you what moles of oxygen. So you cross multiply. So when you cross multiply, you now have x now will be equal to what? 0.13 times 1 divided by 24 dm3. So I'm to use my calculator. 0.13 divided by 24, which will now be equal to 5.42 times 10 raised to power minus 3. 5.42 times 10 raised to power minus 3. So I have to erase this. Yes. So that I can solve the next question. And the next question say the number of moles of electrons needed for this. The number of moles of electrons needed for this. Now, 1 mole of oxygen, if you look at the equation from the equation, 4 moles of electrons generate 1 mole of oxygen. So therefore, 5.42 times 10 raised to the power minus 3 moles of oxygen will generate what number of moles? So you cross multiply. So the number of moles of electrons needed will be X is equal to 4 times 5.42 times 10 raised to the power minus 3, which will not be equal to, if I'm to use my calculator, 5.2 times 4, you now have to now be equal to 0.0217 moles of electrons, which will be equal to 2.17 times 10 raised to the power minus 2 moles of electrons. Yes, I have to erase this so that I can solve the next one. So you have to calculate. The next one is to calculate the number of Coulomb powers. Calculate the number of Coulomb powers. Remember, quantity Q is equal to what? Current multiplied by time. So the current is 1.2 ampere times the time is 30, converted to seconds, multiplied by 60. So you have, so if I'm to use my calculator, I have 1.2 times 30 times 60, which will be equal to 2,160 Coulomb. That is the number of Coulomb passed. Then the next one is what? The number of electrons passed. Okay, I have to calculate the number of electrons passed. 1 electron is equal to 1.6 times 10 raised to the power minus 19. The 1 electron is equal to 1.7 times 10 to the power minus 19 Coulomb. 1 electron will give you 1.6 times 10 raised to the power minus 19 Coulomb. Then 2,160 Coulomb will generate what number of electrons? X. So we'll cross multiply. You now have 2,160 divided by 1.6 times 10 raised to the power minus 19. So if I'm to use my calculator, so I'll have divided by 1.6 times 10 raised to the power minus 19, which will now be equal to 1.35 times 10 raised to the power 22. That's 10 raised to the power 22. So 2,160 divided by 1.6 it will now be equal to 1.35 times 10 raised to the power 22. So that is the number of electrons passed. So I have to erase this so I can solve the next question. So to get the next question, please, I want us to listen attentively. The next one is calculate the number of electrons in 1 mole of electrons, which is the Avogadro's constant. the number of electrons in 1 mole of electrons, which is the Avogadro's constant. The number of electrons in 1 mole of electrons. So the next thing to do, you look at the question very, very well. From what we have, if you look at, you see when a current of 1.2 ampere was passed through dilute sulfuric acid for 30 minutes, it was found that 130 cm of oxygen measured at 25 degrees, 1 also was collected at the anode. So the first thing we need to do here is we need to calculate the Faraday's constant for this particular reaction, for this particular electrolytic process. Now, from what we have here, that for 24 dn cube of oxygen, for 0.13 dn cube of oxygen from the question of oxygen, 2,160 quantity of electricity was passed. So for 24 dn cube of oxygen, which is 1 mole of oxygen, what quantity of electricity we need to calculate that quantity of electricity, X. So when you cross multiply, you now have what? 24 times 2,160 divided by 0.13. So I'm to use my calculator, which is 24 times 2,160 divided by 0.13. So you have 398769.23 coulomb for 24 dn cube of oxygen, which is 1 mole of oxygen, so which is 398769.23 coulomb. So for 1 mole of oxygen, which is 24 dn cube. So if you look at the equation, we need 4 moles of electron is required to deposit what? This 398769.23 coulomb. So if 4 moles of electrons deposit 398769.23 coulomb, then 1 mole of electron will deposit what? 1 mole of electron is going to deposit what quantity of electricity? So we cross multiply, it will now be 398769.23 divided by 4. So 398769.23 divided by 4 to now be equal to 999,692.30. So I have to erase the upper part, so that I'll have enough space. So it will be what? 99692.30 coulomb. So this is the Faraday's constant for this. The Faraday's constant when a current for this electrolytic process, that is when a current of 1.2 ampere was passed through dilute sulfuric acid. So for this experiment, this is the Faraday's constant. So we already have the Faraday's constant. So we are asked to calculate the Avogadro's constant, which is L. L now will be equal to what? F over E. Our Faraday's constant is 99692.30. Then the charge on one electron, which is E. E is the charge on one electron. 1.6 times 10 raised to power minus 19. I have to erase the whole of this so that I will have enough space. So if I'm to use my calculator, so 99692.30 divided by 1.6 99692.30 divided by 1.6 So you have what? 6.23 times 10 raised to power what? 23, which is equivalent to the Avogadro's constant, close to the Avogadro's constant. So for this experiment, the number of electrons in 1 mole of electron, which is Avogadro's constant L, is equal to what? 6.23 times 10 raised to power 23 moles of electrons. So it's as simple as ABC, though the question is more detailed, just to follow it step by step. And I encourage you to solve as many questions as possible. And feel free to reach out to me if you encounter any difficulty or any challenge. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. So feel free to reach out to me. Thank you very much. So still on topical questions on electrolysis. This is a typical examination question. The question before us is a little bit detailed, but it's very simple. So in an experiment, a current of 0.200 ampere was passed through the cell for 40.0 minutes. The mass of silver cathode increased by 0.500 gram. The charge on the electron is 1.60 times 10 to the power minus 19. You have to calculate the number of moles of silver deposited on the cathode, the number of moles of coulombs of charge passed, the number of electrons passed, and the number of electrons needed to deposit 1 mole of silver at the cathode. So the first thing you need to do is to write the equation that takes place at the cathode. So the silver ion, which is metallic ion, goes to the cathode, it gains electron, and to get silver metal. That's the first thing. So you have to calculate the number of moles of silver deposited on the cathode, silver metal deposited on the cathode. So we use number of moles is equal to mass over the relative atomic mass of silver. So you look at the values we are given time, we are given current, we are given mass. So you have to consider the values, then you know what to do. So the number of moles of silver deposited on the cathode, we use the mass over the relative atomic mass of silver. So the mass is 0.500. The relative atomic mass, if you check your periodic table, from the periodic table, the relative atomic mass of silver is 108 gram. So it will now be equal to, you have to calculate. So to calculate the number of moles, 0.500 divided by 108. So you have 0.004 0.00463, approximately 0.00463 moles. So this is the number of moles of silver deposited on the cathode. So the next question is calculate the number of coulombs of charge passed. Using your formula, number of coulomb Q will be equal to what? Current times time. So what do we have here? The current is 0.200 multiplied by the time, which is 40 minutes. 40 times 60. So we'll have, so let me use my calculator. 0.200 multiply by 40, multiply by 60. We have to multiply by 60 to convert the minutes to seconds, which is the standard unit of time. So we'll have 480 columns. So the number of columns of charge passed is equal to 480. So I have to erase this so that I will have enough space to solve. Then the next question is the number of electrons passed. We have to calculate the number of electrons passed. So to get the number of electrons passed, remember 1 electron is equal to 1.60 times 10 raised to the power minus 19 coulomb. Therefore, 480 coulomb will give you how many electrons? So we'll cross multiply. So it will now be what? X now will be equal to 480 divided by 1.60 times 10 raised to the power minus 19. So it will now be equal to, so if I'm to use my calculator, it will be 480 divided by 1.60 so you have 3 times 10 raised to the power 21. So this is the number of electrons passed. 3 times 10 raised to the power 21. Then the next stage, I have to erase this so that I will have enough space to calculate to solve the next question. So the next one is you have to calculate the number of electrons needed to deposit 1 mole of silver at the cathode. That is the Avogadro's constant for this experiment, for this electrolytic process. The number of electrons needed to deposit 1 mole of silver at the cathode. Now, from our question, you discover that 0.500 gram of silver requires 480 coulomb of electricity for it to be discharged. So for 108 grams of silver, which is 1 mole of silver, what quantity of electricity will be required for it to be discharged? So you cross multiply. X now will be equal to 108 times 480 divided by 0.500. So if I'm to use my calculator, 108 multiplied by 480 divided by 0.500. So you have 103 680 coulomb. 680 coulomb. So this is the charge, quantity of charge for 1 mole of electron, which is the Faraday's constant. Because 1 mole is equal to 1 Faraday. And 1 Faraday is equal to 96,500 coulomb. So, but for this particular experiment, the charge is the quantity of charge for 1 mole of electron, which is the Faraday's. So to calculate the Avogadro's constant, we apply a formula. L is equal to what? F over E. The F is the Faraday's constant, and the E is the charge on 1 mole of electron. So the Faraday's constant here is 103 680, and the charge on 1 electron will be equal to 1.60 times 10 raised to the power minus 19. So you now have divided by so what you have is it will now be equal to 6.48 times 10 raised to the power 23. So the Avogadro's constant, which is L, that is the number of electrons, 6.48 times 10 raised to the power 23. So L is equal to 6.48 times 10 raised to the power 23, which is close to the Avogadro's constant. So this is the number of electrons needed for 1 mole of silver to be discharged at the cathode. So it's as simple as ABC. All you need to do is to attempt as many questions as possible. And please feel free to reach out to me if you encounter any difficulty. All you need is just constant practice, and constant practice. And feel free to reach out to me if you encounter any difficulty, or if you encounter any challenge while trying to solve any question. I'm Mr. Joseph, your chemistry teacher. You can go to the comment section and put down your comments, share, like, and subscribe to my YouTube channel for further updates. Thank you very much. Mr. Joe, your chemistry teacher. Thank you for listening. Please subscribe to my YouTube channel, share, like, comment, and feel free to reach out to me if you encounter any difficulty while solving some of these questions. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Feel free to reach out to me if you encounter any difficulty. Thank you for listening. Please don't forget to subscribe to my YouTube channel for further updates.